So, hey, everybody, this is Adventures in Machine Learning podcast. Today on our panel, we have myself, Ben Wilson, and Francois Bertrand.
Hello.
And our guest today is Slater Victoroff, who's going to talk to us today about some very interesting, as we said, bleeding edge research in the future of ML and AI, specifically around multi-modal AI and machine teaching. So welcome to the panel today, Slater.
Thanks so much for having me, Ben. I'm looking forward to the conversation.
Right.
Yeah, no, you sounded really passionate and enthusiastic about these fields you were just describing to us. So that I'm really looking forward to hearing more about these things. So yeah,
the field has been very good to me. What can I say? I'm lucky enough to get to wake up every morning and work on really cool problems. So yeah, I don't know what's not to love.
That's awesome.
I remember working my tail off to become a senior developer. I read every book I could get my hands on. I went to any conference I could and watched the videos about the things that I thought I needed to learn. And eventually, I got that senior developer job. And then I realized that the rest of my career looked just like where I was now. I mean, where was the rush I got from learning? What was I supposed to do to keep growing? And then I found it. I got the chance to mentor some developers. I started a podcast and helped many more developers. I did screencasts and helped even more developers. I kind of became a dev hero, and now I want to help you become one too. And if you're looking forward to something more than doing the same thing at a different job 3 years from now, then join the Dev Heroes Accelerator. I'll walk you through the process of building and growing a following and finding people that you can uniquely help as you build the next stage of your career. You can learn more at devheroesaccelerator.com.
Yeah, take it away. You were talking to us about machine teaching, and I think you were starting with multimodal AI.
Yeah, absolutely. So actually, and Ben, I think it's perfect because you're drinking coffee, I believe, right?
Yes.
So that's actually the example that I always love to use when I explain multimodal AI. So, when we drink a cup of coffee, it's the most natural and normal thing in the world. We barely think about it, right? But when you think about in the body, all of the systems that have to come together in order to actually do that, right? You've got your sense of temperature, right? You've got to obviously be able to visually see the coffee, right? You have to have your sense of, proprioception, where your arm is. You need to feel the weight of the coffee in your hand so you don't spill it. So actually, many things coming together, even though maybe each one of those systems is relatively simple. Now, imagine, if you will, for a moment, that you had to take a sip of your cup of coffee, but instead of doing it the normal way, you have to do it as a purely visual task, right? Your arm is numb. You don't know where it is. You have no sense of temperature, right? You still have to somehow understand whether it's safe to drink. Maybe you can, look at the condensation. Maybe you see some steam rising off the top, right? But you see how very quickly something that is trivial and very, very easy to do becomes almost impossibly difficult when you limit your input to this one modality. And I would argue in a lot of ways, this is kind of one of the key next areas for AI to dive into. So when we think about traditional AI systems, right, even sort of these modern, very impressive systems, though, again, to the bleeding edge point, this has started to change very, very recently. We've got NLP models that deal with text. We've got computer vision models that deal with images. Even the idea that you could have a model that spans, multiple languages in text is very, very recent, that's something that you could actually do. And now what we're starting to see is an expansion actually even beyond that, such that you have single models that can handle image and text together. And so this is sort of this idea of multimodal AI, right? The idea that you can synthesize together different modalities of data to gain sort of a shared understanding and build this general intelligence.
Great. So in concrete ways, what kind of fields are you applying this research, or are you using to research this?
Yeah, absolutely. So the field gets broken down into two really broad spaces. There's the translation problem, which you can imagine things like image captioning, or the recent DALL-E paper, DALL-E, like WALL-E, but DALL-E, by OpenAI. And that's actually a generative model where the idea is you can give it a caption of an image and it will then generate images. And theoretically, those are things that can also operate in two directions. So, you can also give it an image, have it generate a caption. It's really cool. It's very fun, right? One of the things I had to do was generate a walrus jellyfish. It actually leads to this whole really interesting field of, if I'm asking for a walrus jellyfish, right? What's the right way to actually frame that question to the AI such that it gives me what I want? And, they actually put quite a lot of padding around it. It almost looks like a Mad Libs where, walrus and jellyfish then fit into these slots. But it's, a walrus jellyfish chimera, a professional drawing that looks like a walrus jellyfish. It's all this stuff that, obviously I would agree with, but I wouldn't usually think about it. And creating those is now called prompt engineering. So that's actually sort of a new burgeoning field that's kind of come up as a spin. Sorry. So that's all the one problem, translation, going between modalities. There's a separate problem in multimodal AI called fusion, which is combining modalities to make sort of one universal decision. So the example here, and this is very close to what Indico does, is documents, right? You think about a document, and yes, there is text information. I think one of the things that people tend to underestimate is actually how little of the information in documents is pure text, right? I think people often think that documents are pure text. One of the things that we realized is that if you take a document, you OCR it, you take the raw text, and you ask people to find things in the document, they just absolutely can't do it, right? We rely really, really heavily on the formatting and the structured information, right? And we think about tables and embedded images and all sorts of stuff like that in documents. Very, very highly varied. But so you see how you can make some decisions about a document from the image information, and you can make some decisions about a document from the text information that's there, right? But really, to understand it, you need to fuse them, hence fusion, right? In this kind of interesting multimodal way.
That's actually a fascinating example of something that a customer I was working with about 6 months ago. They were actually doing a multi-phase process on document classification, and they were struggling with the same thing. The content is so similar in the actual text extract that we're not getting a good signal here. And it's sort of focusing on features that don't seem to be relevant to what we're trying to classify. So signal to noise ratio is really bad.
Yeah.
And we collectively came up with the idea of what if we just take an image scan of the document and just run that through a transfer learning CNN? We just retrained it on their document images, and it increased the accuracy by 40% by just doing that and combining ensembling. So that's fascinating, talking about building a single model that can actually look at both of those at the same time.
Right. Because I think that's very indicative of what a lot of people are doing, right? And documents, they're tricky, right? And I think what you end up doing in practice is both the image side of things is tricky. Transfer learning CNNs are a lot more accessible today than they were 6 years ago, but it's still not a trivial thing, right? And then also text is tricky, right? They're both separately difficult problems, right? And then in practice, what you often have to do to sort of solve this whole document use case is you put 8 to 10 of these things together, and you've got heuristics combining them, and then also just the infrastructure actually to load them in and out and transfer them, because these binary blobs are huge and kind of unwieldy and don't work normally in a lot of ways. It's tough stuff. Yeah. So I don't know. That's kind of why that's one of the reasons that we think it's such a compelling space, is just having done it the other way for so long. It's really tough manually fusing them and figuring out where you make decisions on one versus the other. And it's just really tricky otherwise.
I'm actually curious about different modes that you define. For example, do you ever view the problem as, for example, let's say in language processing, context as a different mode, looking back in time, and so within the same medium, you're saying, okay, we usually do language processing this way, but what about adding a context component, looking back farther and that kind of stuff as a different mode?
So I think the thing that I think is very interesting, specifically talking about modes, is there's the obvious modes, right? I think text, image, audio, right? You can think those are kind of obvious modes, but then I think there's a lot less obvious modes. One, for instance, I think that's really impactful is metadata generically, right? So the idea, and this could be longer context, but I actually think that the more impactful thing, and actually, this will get into machine teaching in a little bit, but actually, I would say the models today, they absolutely 100% have the capacity to reason over extremely long sequences. The problem is that we have no idea how to effectively encourage them to do so, right? It's just like it's too easy for them to find shortcuts, so to speak. But one of the things that I then think is really, really interesting, because I think what you said, that word context is really key, is so two modalities, for instance, that I think are really interesting that you can think of in a document context and a language context. One is graph distances generically. So you think of a parse tree in a sentence, right? And that actually, I think, is a really great example of a modality. And often that information is sort of implicitly in embeddings. There's that great paper visualizing the geometry of BERT that shows how, like, yes, in the embeddings, theoretically, that information is there. But by making that explicit and actually allowing also supervision, through that surface, right, you can also improve the understanding overall. And I think that, you can think metadata as well, I think just often comes into it. You think I might have the author of this particular document, or even, say that I want to classify the first page as, this is document A, B, or C. That then becomes sort of a piece of metadata that you use to help make those downstream decisions.
Do you think there's some amount of domain expertise, domain knowledge to apply to each problem to create modes or to kind of do that?
Yeah, absolutely. I'm a huge advocate. Sometimes we call Indico a bionic arm, just because my view is very much that humans and machines are like a better together kind of situation. And so I believe very much I believe in that very much.
Yeah, that's interesting, because I was thinking about Google, I think on their latest OK Google. Okay, I might have triggered a bunch of devices. I'm sorry. when they say you set an alarm for 4:00, right? And then they said their latest improvement was that, if you say, make that 8, or having the context of what is that. But then that being that was a huge advance for them, or something, recently, or the latest version. But yeah, that felt like either that, or, this is where you draw the line. Where do you just have a human say, okay, in this context, look at the previous query, or have that completely automated? And it's always a tension between just letting the machine figure it out, or have a human say, okay, if somebody says this or that means look at the previous one and kind of do this separate processing. It's a bit hard-coded, but sometimes in AI feels like, some human intervention can help.
Yeah, and I think that you're right. I think it's a bit of an existential question. I think what I always like to ask myself is, or I think the important question usually to ask in a lot of these cases is this a human problem or is this a machine problem, right? So, for instance, right, I think that in the limit, because things theoretically can be solved with AI, we often kind of pull ourselves away from actually, just to maybe give a good example, like think loan approvals. That's an example of something that Indico handles, all the time. We really want to believe that the way that each human does that process is exactly the same.
It
turns out, yeah, exactly. It is absolutely not. And then that sort of opens up this whole question of, okay, then what is the appropriate thing for the machine to do in that context? And you can either say, oh, well, the machine will figure it out. Or you can be like, no, actually, the problem is still a human problem. And it's let's first get an alignment, right? And then we can actually figure out what the right step forward is. And I think so often that is actually where use cases fall down, is just humans articulating the problem in a consistent way.
Or the sort of the meta problem we're dancing around right now, which is in any AI system, particularly with deep learning applications, you have to be very careful about what your training data is, because most of the time, a human or a group of humans generated that through their action or the observation of their actions. And That's where I see a lot of field applications, particularly in NLP, of people who are building something. The corpus is far too large for any human to read and understand themselves. You could not hire enough humans at a company to read through and vet all of that data.
Honestly, the concept of what vetting means is even not well defined.
Exactly. You'd have to set those limits in heuristics-based code to say, I am going to be looking out for this sort of pattern because I know this is socially acceptable, or this breaks our social contract with our customers or with society in general. Here's the things that we don't want it to do. Somebody's got to figure out what those are. Somebody's got to work with links.
Before we even get to the heuristic-based code, I think we have to agree societally what those are, right? Exactly. I think that's the real problem. And that's, I think, a lot what I mean by, you think a lot of times when we look at these ML problems, they are actually human problems, right? Mm-hmm. It's like, if we can come up with those definitions, it's not that implementing them is particularly hard, right? For any definition we can come up with, and you know, folks, to give credit, they have made progress here. It's like 4 definitions of fairness we can go and measure and determine whether we're doing it. But it's coming up with those measures of fairness, right? It's getting the data to actually backstop it, right? And it's kind of building a system that cares or has any real incentive to care. I think the analogy that I often use is, it's like a mirror, but it's very much not a perfect mirror. It's a mirror that's got 100 different pockmarks kind of across the surface. And so of the things you show at it, it's going to pick more or less random pieces of that to ignore or amplify and focus, right? And I think one of the things that we miss is that when we don't make assertions about what's right and what's wrong in those assumptions, right? It's not that the ML is then not making those assumptions, is that the ML is then making them random, right? And actually, one paper that I just absolutely suggest everyone read is the under specification paper by Google that just goes into this problem in a huge amount of detail. And actually, one of the things that you said that I do want to call out is, you said particularly in deep learning. And I think that's actually a misnomer. It's something that so it's important in all ML. When you actually characterize the problems of bias and sort of this imperfect reflection, they are dramatically more severe in traditional ML systems.
But they're easier to detect and easier to change.
No, they're not, is the thing, right? So those are out in production. There is no way to change them, right? And in fact, they have insulated themselves from those impacts. And they're, again, dramatically more severe. And people use the fact that, so like a great example, right, is that people often look at explainability in a linear regression and they're like, oh, you know, like, I know the slope is 4. Great. Like, my point of view, that's absolutely not explainability. Treating that as explainability is incredibly irresponsible, because the question that we have to ask is, why is the number 4? What is the impact of that number being 4, right? And you see, that's, I think, where we give ourselves sort of this out, like, because we could theoretically change it from a 4, we count that as explainability. We sort of like pat ourselves on the back. We're like, job well done, right? And that's why I just like, and the thing is, because the flip side is that what we actually need to do is we need to come up with data-driven ways of ensuring that these are fair after the fact. Like, it's not that, oh, it needs to be 3.5 instead of 4. It's that setting it arbitrarily in absence of data will always be irresponsible. And once you've got the data, it doesn't matter whether it's a deep learning model or not. In fact, I would argue that once you have the data, you are certain that a deep learning model can actually take advantage of that, where a traditional model may just fundamentally be biased. Like, there's no way to train a linear regressor on top of zip code data that is not racist, right? You just can't do it. You can theoretically do that with a deep learning model if you've got the proper objective. So that's my thoughts.
Yeah, my allusion to that was just in the temporal sense. So if we run something like SHAP or LIME against a linear regression model, we'll get that analysis done, even if we're talking about hundreds of gigabytes of training data. We'll do that simulation and we'll get an answer in a day to say, here's the things that are impacting this. I ran a bunch of simulation on some synthetic features to try to tease out how this model responds to these sensitive attributes within our feature set. With deep learning, you can do the exact same thing. And I've worked with companies that do it. It just takes a lot of more time to do it. And it's a lot more money to run simulations like that from my experience, because we might be doing hundreds of thousands or millions of simulated conditional edge cases to say, is this going to make a prediction that is going to blow up in our face? Like, are we going to get a call from a customer because of the output of this model? And then tweaking that and saying, all right, now we have to change our actual tensor that's coming in for training to adapt, so that the time duration that I found for adjusting deep learning to accommodate for that just takes longer. And in production at most companies, that's what your big budget is. It's how long is it going to take to get this thing to production? That was all I was alluding to, is that it can be more complex.
I think it's more of a lack of infrastructure and understanding of the skills, right? Because the process at the end of the day is exactly the same. And I would kind of argue that even sort of the underlying conception here, that it's you've deployed something bad to production and you're fixing it in like an oh shit kind of moment, right? Like I would say like we're already in a bad spot there, right? Which I mean is fair. You do definitely have to fix that. But I think my point of view again is that that's not the approach that we ought to be taking. Is like it's just different training regimens up front, right? And then it's the same either way, right? And it's again like when you're limited in capacity, like do you know the 4/5 rule?
4/5.
Yeah.
No.
This is like it's like the most disgusting thing in the world, right? But this is exactly kind of what I'm talking about. In specifically like underwriting cases and things like that, when you're showing disparate impact. There is a rule basically because these models have such low capacity and your ability to mitigate bias is just fundamentally kneecapped and you can't really do anything about it. That so long as your bias like is not greater than 4/5, it doesn't count as bias.
That's a little scary.
It's really bad, right?
Yeah.
It's really bad. Yeah. And I don't know, like when I learned about this, I was just like, I was livid. I'm like, wow, great. Like we've moved from 3/5 to 4/5. Good job. You know, I don't know. But then I think that the other problem is that people are, again, just not really willing to encode a lot of these metrics of fairness. Like, I think if you look at the Amazon resume reviewer, right? Deploy automated resume reviewer results in gender bias in resume reviews. The obvious conclusion is Amazon has been running a biased process for years because, you know, how else did it get there? Solution is not, oh, let's fix the process. Solution is, let's turn off the predictive piece such that we are no longer measuring the bias and no longer have to confront this truth.
Yikes.
Which, I mean, I don't know. I think that's what a lot of people are doing. I don't know. It's the careful thing about AI, right? Is I think in a lot of ways, what it's really doing, it's illuminating things that are already there, but they're very uncomfortable truths and not necessarily ones that we are well equipped to fix yet.
Hey, I've got to. Sorry, Ben. Did you want to?
No, go ahead.
No. I unfortunately, for personal reasons, I have to take off 5 minutes ago. But I'll stick around. I'd love to hear. This has been really entertaining, by the way. It's great to have some back and forth. You were talking about machine teaching and how that was, you were almost touching upon that. And I'd love to hear that before taking off here.
No, sorry, that's a great point. So machine teaching at a very high level is a paradigm that says what's important is not how we can easily structure sort of objective functions for machines to learn, but is instead thinking, how do humans typically teach problems? It's related, though not immediately in an obvious way, to the under specification paper, where the focus of machine teaching is very much building intuitive interfaces that, again, align with the way that humans typically teach other humans how to do tasks. But the thing that's really interesting kind of underlying that is it means that you're not dealing with traditional supervision targets like a classification target. Right. And it starts to ask these interesting things like maybe the way someone teaches another person this is, they construct a parse tree for this document. Right. And you get into all of these like really interesting or maybe the way they do it is they show, good and bad examples of something. Right. But they're doing it explicitly in a relative way where this is better than, worse than, but they can't say in absolute terms, this is good, this is bad, if you follow. So, it kind of triggers all of these really, really interesting pieces. But the thing that's really encouraging is that in cases where we have successfully designed sort of new methods of supervision, they often result in dramatically higher efficacies for these models downstream. So like a very, very simple example, something that we would call a sort of explanation-driven classification. If you take straight object detection and you have a bunch of images and say there's a relevant thing in the center that you're trying to classify, say, I don't know, it's like a stack of cash and you're trying to figure out if it's big or small. If you just give it a whole bunch of images and treat it as a classification task, it'll make progress. It'll sort of work. You'll chip away at it, but it'll have all sorts of edge cases and actually won't be perfect. If you instead train first a model to, isolate the stack of cash, that's actually a very easy problem. And then a secondary model to, classify an image of, a perfectly cropped stack of cash, that's also a very, very easy problem. So by sort of breaking it apart, adding additional human supervision that's just a little bit more explicit, that again, that's how a human would probably teach another human how to do it, you just radically improve the efficacy of these models with dramatically smaller amounts of data.
So again, that's touching upon the domain knowledge, applying that to the learning process, basically.
Yeah. I think getting subject matter experts as close as possible. I think that CLIP was a paper that really recently, I don't know, I thought was very insightful because they sort of pointed out that as cool as zero-shot learning is, it's sort of fundamentally a bad problem because there's context to everything. And so they sort of said that the much more interesting problem is just performance at minimal context expression, which is actually a really importantly different line than zero. It gets into that prompt engineering stuff as well, where that's one of the ways that people sort of pad out these zero-shot framings with context.
Do you see a natural progression in something like machine training, say 20 years from now? Do you think that the industry is going to move towards sort of self-rearranging AI that'll say, I'm going to attempt internally during optimization to try these different paradigms, and I'm going to start going with the structure that makes the most sense for solving this?
I definitely, I think that to the extent that it is possible, yes, right? I think it's one of the things that interacts really. So traditionally, because there's been no need for this, sort of the formats that we've standardized for everything don't really support that kind of a thing. But for instance, right, because I actually think that yes, absolutely, but I think it's going to take a while to get there. I think that within a mode, so like in text, for instance, we have something we call the span API. So the idea is, if you're extracting a particular value, maybe you want to do page classification or paragraph classification or sentence classification or something like that upstream. No matter what, if you've got that span isolated, you have the data to get that theoretically. It's just you don't usually have your ETL pipeline set up to do it. So I think that's a great example of where absolutely I think that kind of optimization internally is super compelling.
That does sound like a second order of machine learning. Like that, this is when how the machines take over. Like they learn how to learn better, and then it's it feels like it could be a huge leverage down the road if you can get not only it's from unsupervised. You're adding another layer of machines taking care of tasks and to get better.
I guess I like to think of it very much as control panes, right? I think that in a lot of ways, and maybe this is a straw man, but maybe it's not. If we hold up zero-shot learning, because we have zero-shot learning today, I think a lot of people today are just like, yep, zero-shot learning is great. That's what we're aiming for, is just like a magic box that spits stuff out, right? And I think that actually shifting towards this notion of these more explicit supervision paradigms, in some ways, it's actually a step back. I like to think of these as control panes, right? I think that we've gotten to the point where actually the power of these ML models has vastly outstripped our ability to use them flexibly, is that we know that there's way more kind of power in there than we're taking advantage of. And it's not even close, right? So that's, I think, how I would sort of frame it, is that it is much more this idea of how do we put humans more tightly at the center of what we're already doing and give ourselves sort of a drastically larger array of kind of, control panes, like build the right interface for us such that we're maximally effective together.
And one of the things that I've seen as key to that is when talking about new tech that companies such as the one that I work for is working on, for instance, AutoML. And that's something where machines are learning to optimize code generation that hopefully solves a problem with less bias or just solves it better. And that's the intention.
According to whatever objective you give it, right?
Right. And one of the things that earlier attempts at AutoML amongst industry was focusing on sort of a black box. Like there's insane complexity happening behind the scenes, and people are like, well, we don't want to expose that to the user. And there's a gradient there of like how complex those things can get. But at the end of the day, you have an artifact that comes out of this, or a service that's exposing an API that you can pass your data into, and it'll just magically do all the stuff for you. And what we're seeing customers actually ask for is not that. People want the transparent box because they need to be able to see the actual code that's generated so that they can modify and interact with it and understand what was actually built. And seeing that as a possible solution for that machine-human interface is fascinating. It almost seems like we're going back in time to reduce complexity and getting away from the black box approach, but using more powerful technology.
I totally agree. So, here's like a fun little stat is that we find upwards of 80% of all production issues actually can be traced directly back to training data, right?
Mm-hmm.
And I think no person in the ML field who hears that is surprised. They're like, oh, I mean, yeah, like I've looked at my training data. But I think that to your point, right, when you're feeding something into kind of a totally closed off black box, your ability to identify and assess that, it's like zero, right? And you just then have those errors forever. Right. So it's actually one thing that, we advocate for very, very strongly. And I think it's something that I both think explainability is like really, really important and tend to be really critical about the explainability space, just because I think that folks stop short of what I would consider true explainability. Just because I believe without remediation, you haven't really addressed explainability. Right. Unless someone can like step in and actually fix it, identify and not even just fix it, but understand, okay, from a process perspective, how did this happen in the first place? Right.
Yeah. Almost like an RCA, like root cause analysis of that bias to say, what does this expose about how our company does business, how we collect data, how we interact with reality, and what can we do about it? And that's really when I talk to customers that are saying, we want explainable AI, I'm like, no. You want to know why your customers are interacting with you in the way that they are. I guarantee you don't care about why the model is making this decision. You care about that underlying reason.
It's just, I think people mean very different things with explainability, right?
Yes.
And that's why I say like feature visualizations aren't explainability. Well, I divide it into formal and functional.
Oh, hey, Slater, I need to go. Just wanted to say this has been a blast. I loved every minute of it. Bleeding edge stuff, explainability, the modes and all of that. It's been great. So loved it. And maybe we'll have you again at some point. But yeah, check it out. Thanks. It's been great.
Awesome.
Take it easy.
Take it easy.
Tons of fun. Thanks.
So with the modality of explainability about
right. So I like to divide it into formal versus functional explainability. And the idea is that formal explainability is really, really key for researchers. That's where actually, feature visualizations are useful, right? Like you actually are diving into the weeds and figuring out, hey, do I need to tweak this architecture, right? And that's really the problem that you're solving. But that is the problem that, 1% of all the people in ML have, right? And vastly more people have this problem that I would call functional explainability, right? That is much more this RCA kind of like, how did this happen, right? Because again, like with what folks are deploying it into production, it's actually pretty rare that you're going to run into a modeling issue. Like for AutoML, right? For all of the complexity behind it, 90% of the time, you're still shipping XGBoost into production, right?
I mean, a lot of people are, yes.
Yeah, I'm being like a little glib, but often, even though the process of getting there is really, really complex, what's ultimately going out is often not that complicated.
Right.
Yeah, actually, as like a little fun side, do you know where the term black box comes from historically?
No.
Yeah, so this actually, I think, is super fun. And it shows actually how I think notions of explainability change as complexity of a system increases, right? So the original black boxes are integrated circuits, right? Mm-hmm. So for folks that have, ever broken computers apart, right, they're these literal black plastic acrylic boxes that are on top of these circuits. And actually, today we use black box to mean you cannot introspect something, right? And in the original days, it was actually the exact inverse, is that a black box was how you achieved explainability in a system. And it wasn't that you couldn't look at the details of the system. It was that you no longer had to. Right. Yeah. And you saw this really, really interesting notion where, like, obviously for any integrated circuit, like no matter how complicated the CPU is, like, yes, you can produce a circuit diagram for it. Right. And, in some view, that is ultimate explainability. Right. But a human could never effectively make use of that information, right? And it's not that we don't understand what's happening in the CPU. It's like, no, we understand exactly what's happening, right? What we don't understand is how do we effectively distill that information into an interface that meaningfully conveys that information to a human, right? Allows them to debug it appropriately, right? Allows them to dive into additional levels of detail as they may need to, right? And this is why I love model cards, right? You see actually sort of this point in, and it's actually funny, is like they hit about the number of transistors that we hit in terms of number of parameters and hit exactly the same like existential crisis of like, oh, we can't keep showing things the same way. And you saw the rise of the data sheet then, right? And I think people are now coming up with these model cards. Great idea. I think with all the competing different model card standards, I think probably there's still something still to come there that will do a better job. But I think it's a great evolution and a real step towards true explainability.
Yeah, and it's something that you touched on earlier, which resonates with me with, hey, I've got feature importances on XGBoost, and that's my explainability. And I find it pretty common that I have to have the chat with people about what is the difference between correlation and causality.
Yeah.
And then that goes into a discussion of what is causal modeling. Explaining
yes,
here is a DAG that you create, and here's all your simulations, and this is how you get an approximation of causality. And when I have that discussion with ML teams where there's nobody who's sort of been around for more than 5 or 6 years in data science world, I get this glassed over look on people's faces. They're like, what is this guy talking about? And do you think that one of the inevitable ways to enhance explainability that reaches not just explain this black box that we've created, as well as explain the underlying business problem that we've created by the way that we do things, is utilizing AI to do some sort of inspection of causality?
I mean, I used to have an old saying is like, I think only Judea Pearl really understands causality, which I think I've stepped back from that a bit, but I think it's something that people don't understand. I think people hear that all the time. They're like, correlation is not causality. It's like, okay, yes. What they don't usually understand is, and it's only very recently that we've kind of mathematically uncovered the tools that we need to truly investigate causality. And I think that is one of the, so I guess the short is like, yes, I think I was reading through causality, and I think especially in the structured data space, right? I guess the trouble is that it's sort of one of those books and one of those fields that is a lot better at pointing out problems than necessarily solutions. And I think it's something that people often grapple with in AI and ML in general, right? Is people generally don't like the answer that they're not actually set up to succeed yet, right?
Correct.
And unfortunately, that is sort of the answer for a lot of folks. I find myself often in the really uncomfortable position, even more basic things, which is like, hey, look, if you actually even wanted to model this at all, forget even having a real causality chain here. You needed to 20 years ago be capturing your data differently, right?
Yes.
And saying sorry, it's all useless. We can't really do anything with this. So yeah, I mean, I think that certainly I hope that, especially, I think the other thing that's tough is that structured and unstructured data operate so differently in the causality space, right?
Oh yeah, for sure.
Structured data, I would say absolutely. And I think we've already started to see some of these graph-based models that do incorporate causality in ways, but I mean, it's so in its infancy. Mm-hmm. I would like to see it become a lot more common, right? Become sort of the de facto way that we think about models as we almost build out these theoretical causality DAGs, right? And then test them, right? Like BDD, right? But right. For causality in ML. I think that unstructured data is unfortunately a bizarrely sort of different thing, because you can't ask someone to do that, right? Which, and it kind of throws me for a loop, right? So I think that what the point of view that we've sort of taken on unstructured data is that the focus has to be tools for people to reach consensus. I think that's really the gap with unstructured data, is that, we find that whatever Bob and Sue have been doing loan processing for 40 years, right? And they've been sitting next to each other for 40 years. And they actually have two totally different understandings of the process, right? Mm-hmm. And they've never talked about it somehow in 40 years. And you see this all the time, everywhere. And that, I think, is one of the things that's really, really missing is, again, how do you have that conversation? How do you actually build consensus? What is fair? How are we going to test this? What are we comfortable with? What is the right answer in this ambiguous case?
Hey folks, it's Charles Max Wood, and I just wanted to jump in here and let you know about something that I'm doing. It's free. It's out there just to help you get answers to your questions about the things that you're running into with your career. So if you have questions about how to get further ahead in your career, how to start a podcast, how to get a better job, how to get a raise, how to deal with a situation at work with your boss, or just maybe you're stuck and you don't know where to go next. How do I get from junior to senior to whatever's next? How do I become a speaker? How do I get to the next level. That's what I'm out here to do. So every Wednesday at 12 o'clock Mountain Time, I'm going to be doing a call, and it's going to be free, totally free. Go to devchat.tv/level up, and you can register for the call. It's using Zoom's webinar software, so it's pretty straightforward. And what we're going to be doing is I'll do 10 minutes, and I'll just show you how I do some form of how I level up, and then we'll just answer questions. And it's not going to be a question and answer like, hey, what's your favorite flavor of ice cream? And then I say Rocky Road or whatever, right? Instead, what we're looking for is more along the lines of, yeah, I have this situation. How do I handle it? I'm trying to figure this thing out. How do I figure it out? I'm trying to stay current. How do I stay current? And if you have any of those kinds of questions, I'll bring you on the call. We'll ask some deeper questions. We'll make sure we get you a solid answer. And I'm really looking forward to helping some people out. There will be no sales, no selling, no nothing on these calls. It is literally just 10 minutes of training and then Q&A. So you can go check it out at devchat.tv/level up.
Yeah. I mean, that brings back a fun like series of tasks that I dealt with at a previous job where we all were under the assumption we had a bunch of data. It was unstructured text data, and we needed to get labels associated with it of like, hey, what is the context of this? And we created a form to have experts internally at the company fill out some stuff. And we wanted to get enough sample data to basically train a deep learning model to kind of do that.
Yeah.
And we sent out that form. We got the responses back. Like, great, this is awesome. We got all these labels. Let's train the model. And it was so unpredictable and useless. And we were like, what is going on? And then we had a software developer that was working on the team, and he's like, hey, why don't you just do quorum voting? Like, oh, okay. So you want to get consensus from people by sending out the same like example to people. And he's like, yeah, but you need a lot more than what you can do inside the company. So our algorithm was Amazon Mechanical Turk to get just random people that have no interaction with one another to try to just vote how their minds see it.
Yeah.
The amount of 100% agreement across a quorum, which we actually had to take our quorum up to 11 in order to get like effective training data.
Wow.
It was less than 0.01% of all 11 agreeing on the same thing. It's crazy how we all see things differently. So imagine how our data is influenced in the same way.
Absolutely. It's one of the things that I think people don't really appreciate enough. So I talk sometimes about the data spectrum. So sentiment analysis, I think, is a perfect example, right? I think someone asked me one day, like, when are we going to have 100% accurate sentiment analysis, right? Because they're like, oh, I've been hearing about this for 40 years. I'm just like, that's never. It's just not a thing that's ever going to exist. And machines are definitely not the problem, right? Because I think everyone's familiar with gold standard data, right? Which is usually, let's say you've got binary sentiment analysis and you've got some kind of voting together to turn it into gold standard, right? Mm-hmm. I think folks sometimes know about bronze standard data as well, which, just sort of unsupervised data, that's bronze standard. There is sort of this middle area of silver standard that was like really, really popular a couple of years ago, but is like less popular nowadays, where basically you've got an objective function that is monotonically tied to correctness, but it's not like gold standard where you can actually sort of track an objective and say like, this is how well we'll perform on a downstream task.
Right.
But I think what's actually even more interesting is that I think you can think about data on the like positive side to that, right? I think there's been a lot of investigation sort of left of gold, but very little right of gold. So I think, for instance, if you think about binary sentiment analysis, I'd argue that binary sentiment analysis is actually sort of this non-deterministic collapse of a dramatically more deterministic upstream process, right? That's actually something closer to aspect-oriented sentiment analysis, where there's actually like several things going on in the sentence. Not all are related to binary sentiment. And so, I like to say that anything that gets you beyond gold in terms of your problem understanding, in terms of how you're tagging the data, that's platinum. And then you can think even of diamond standard data, and there, in Google's sort of paper, they sort of introduced this notion of decidability, right? And the idea is like diamond standard data is anything where you can show that 100% actually exists for this data set, for instance. And for a lot of data, like diamond probably doesn't even exist, right? It's not something that humans are capable of if there's like any fuzziness to the problem at all. But I think people often assume that gold is diamond, is the issue.
Yeah, and it is not, particularly when you're talking about a construct as fundamentally flawed as human language, and how we all interpret it differently based on the inherent bias within our own heads and how we see reality. The best way to think about it is look at any bit of Twitter and any post done by anyone about how many different reactions you get to that, of like a sarcastic post or something by somebody who you wouldn't expect them to be sarcastic. Some people get the joke, some people get like the context of it, and then you have a bunch of people just flip out and freak out about the response. And that is our reality of language. And that's why I think it's nigh impossible with the constructs of human language to get 100% certainty on something like sentiment.
Even I think some of the older examples were, if you look at judges making decisions before and after lunch, because like even you as, an individual, if you look at the same tweet at a different time when you're in a good mood or a bad mood, you might read it totally differently, right? Yeah. So I think it's both what's kind of wonderful about, humans, that we can kind of take all of that into consideration and make these instant decisions. It's also why I think that the right move is really not sort of these fully autonomous robot workers that sit next to humans. I just dramatically prefer this analogy of the bionic arm, that it's like, it's about, right. It's not like there's some objective thing that we're trying to map to. It's like, no, like these are human mimicry machines. Like, let's lean into that and like let humans use them in that way responsibly.
Right. Because the one thing that AI in general can do that we can't do is chunk through data infinitely faster than we can.
Yes.
So that's where I see this field going in general. And I 100% agree with you, is that it is, all of these tools and techniques are not a replacement to our own minds and just blindly relying on data. They're an extension of our minds and a means of detecting and identifying the underlying bias that exists in our data and exposing what those latent variables are that we're not capturing.
That's one of the things that I always just see as the massive potential of AI, right? Mm-hmm. And I think people are, and I mean, reasonably so, right? They're very, very focused on the bias in AI, and people should be, because the downside there, right, is we encode this bias forever, right?
Right.
But the flip side, right? And here's where I think I'm cynical on a lot of things, but this is actually a point that I'm maybe naively optimistic on, is that for the first time, we can like measure it in a really, really detailed way. There was this paper out of Stanford that really opened my eyes about measuring ethnic bias in like 150 years of literature. And basically what they did was they trained, word embeddings on literature that came out over the course of 150 years, and basically found these places where, and so they did sort of a normalization scheme where they're just like, we assume that like this ethnicity should be pretty much the same distance from, like these characteristics, like there shouldn't be a big bias. And then they actually, again, were able to quantify how biases sort of changed over the course of 100 years. And it was interesting also because they referenced it in terms of these overly strong connections to words that then, had negative connotations with them. But it was also, a way of communicating that bias that was then immediately intuitive to humans, right? It wasn't like, oh, the bias went from 0.4 to 0.8. It was like, yeah, we used to really strongly associate like folks of this ethnicity with these bad words. Now we associate them with these bad words.
Dude, it's right? Different bad words.
Yeah.
Or from a linguistics point of view, in your specialty, how do you deal with the mutability of language over time?
So it's kind of funny because as my night job, I don't know, like in my off time, I am a writer as well. So I write science fiction, and I am obviously a big reader as well. So it's one of the things I love about English. And I actually do think this is something that is very different language to language. But English is actually profoundly inexpressive language in a lot of ways. If you look at sort of the way in which it's constructed, it's not like Chinese or something where each character has a massive amount of like meaning impounded into it, right? So what that means is that the way that our language changes is actually really interesting and unique, where kind of individual words have their meanings transformed over time, and folks just like create new words wholesale, right? And those are really, really interesting things that you just don't see happen the same way in other languages. And so, for instance, one of the huge breakthroughs in the space, or one of the huge problems in NLP generically, was like, what is a word even, right? Even the fundamental idea that you're going to take text, break it down into words, and then analyze words, turns out that concept actually breaks down relatively quickly, right? It was one of the, and we first had eye-opening experiments where by changing the tokenization that you use for an algorithm would have more impact than the algorithm itself. I was like, wow, that's crazy. And then there was this secondary breakthrough of subword level tokens and BPEs, right, by pair encodings. And this, I think this is unfortunately, it's not super useful for languages outside of English, but it's really, really critical for English. But it's the idea of, it's just like this whole separate question of like, how do you effectively break language down into these base units such that you can reason across them? I think ultimately solutions will have to work on a character level to get there. And they're just not quite that smart yet. Yeah. So I don't know. That's kind of my view. I think that the other thing is that people, I think, are a little too obsessed with this notion of like the model that they see as like a static thing. And I think that model is also going away. I think that so many of the advances going forward, right, there are these notions of very different data flows, right, like federated learning, things that dictate model updates and things like that. So I think that, and, model surgery as well, it's worth Googling, but I think that we're moving very rapidly into this new paradigm of models where like, you're not really building models from scratch anymore, right? But you're instead dealing with like model lineages that are pretty much all going to be leveraging some prior information. And there was actually that massive paper out of Stanford recently. It's like on the opportunities and risks of foundation models, something like that.
Yeah, I mean, I see the same in industry, 100%. With transfer learning is becoming more and more appealing to people once they understand what the total cost is. When, I've talked to teams before that are like, yeah, we've been working on this deep learning CNN. We're going to create a GAN here. And like, yeah, that's cool. How's it going? You've been working on it for 6 months. Like, well,
it's a lot of
really
fun.
Expensive. Yeah,
it's expensive and fun.
The business really wants us to show some progress. Like, here you go. Here's ResNet. We're gonna lock 80% of this thing. We're gonna retrain it on your data. It's not going to be as perfect as your homegrown one, but it'll get something out there, and you can iterate over time on your own solution. And I see that more and more commonly as the years have gone by, working with so many customers.
Yeah, it's funny. Like transfer learning was like Indico's original thing. Like, 7 years ago when we were founded, we're like, this is how we're breaking through. And I remember 7 years ago, like deep learning was barely a thing. So trying to explain to someone the impact that transfer learning had in deep learning, I mean, it wasn't even like I was speaking a language. It was like I was from another planet. Right. And I think it was really, really cool to see it go from what on earth is that to just like deep learning is super impractical to like, I would actually even go so far as to assert like, if you are working near the leading edge, transfer learning, it's almost like irresponsible not to use it. It's so impactful for use cases. And I think, again, it's especially on the image side, it's gotten radically more accessible than it was, months and years ago, right? It's getting better constantly. Language has always been a bit slower, right? But I think also a lot of progress is being made there. But I think it's sort of this secondary aspect where, we used to talk about how like, oh yeah, transfer learning is our competitive edge. I think it's such a massive field that it really doesn't make sense to talk about it like that anymore. I think my view is much more that transfer learning is a massive field, one that it's sort of the art and science of reusing old models to solve new problems. And because it is an art and a science, it's not only developing at a just stupid pace in academia, but it also is just really tough it's like, it helps really, really rapidly. And then there's also so many more benefits you can get from it over time as you optimize it. I think it's really, really interesting.
Yeah, definitely. I can echo that, and in pretty much every conversation that I have with teams of like, this has now become what was fringe before, or it's just this outside idea of like, you could do that. how do I do that? To now it's like, oh yeah, that's how we do that. That's how everybody does that.
Yeah.
And it's amazing how fast all of this is changing too.
Totally.
I worked the first job that I did working with data scientists before we were called data scientists, when we were called like analysis engineers or statisticians.
Yes. Yeah.
But I worked with this gentleman who was a statistician at a company, and he was talking about the glacial pace of different rises and falls of AI since when he started. And he started his career in 1981. And he's like, I was there in the 80s when everybody was talking about neural networks. And now it's like AI is making this rise again. He's like, it's just a neural network that has this extra loop in it. And he's like, there's nothing new here. And I was like, yeah, but now we have computing that can do it. He's like, that's the differentiator. And he's like, you get enough smart people who understand this stuff. He's like, you'll see this take off again the right way. And it's how prescient he was. And this is a decade ago.
So I'm going to give you something to Google, because that guy probably doesn't realize it, but he's a part of an arc much, much older than that. Yeah. So
it goes back to the 1800s. I mean,
I was going to be a little bit more. So the book that I think everyone should read that is going to make you feel like you're living in the Twilight Zone is called Alchemy and Artificial Intelligence by
Dreyfus.
Yes. Sorry, Hubert Dreyfus. But he is one of the inspirations for Hubert Farnsworth, the Futurama character. Actually, one of the main writers behind Futurama had him as a professor randomly. But so back in the 60s, he publishes this book called Alchemy and AI. And I swear, if you didn't know when it was written, it could have been published yesterday. And what he basically does, in a lot of ways, I think so back when he got brought in, so his background was very much in sort of linguistics and philosophy. And he was brought in sort of the 50s and 60s when AI was going through its very first peak hype. There's this quote I used to use to express this to people, which is from 1950. In 1954, the US military had a statement saying, machine translation will be a solved problem in 3 years. So it's like 1954, right? You just have to let that sink in for a moment. Mm-hmm. It's like someone could say that today, right? I mean, and maybe they would be more right, but I don't know. And Hubert Dreyfus basically comes out just panning everyone, because the whole way that you built AI back in the day, and frankly still today to a large extent, right, it was all symbolic based, massive taxonomies. It was sort of built on this fundamental idea that if you build out enough keywords, right, if you just if your taxonomy is big enough, you'll eventually get it all. And he basically just says, I have no idea why anyone thinks this is true. I have asked a lot of people. No one can give me any compelling reason other than it's worked for other fields. And he's just like, this is wrong. This isn't going to work, period. Right? Everyone pans him. In fact, he's so hated by the community. Everyone in their mother comes out and they're like, all right, we may all disagree, but we're all putting our disagreements to the side to call this guy an idiot. He was a tenured professor at MIT. He left to become an associate professor at Berkeley, right? So it's very, very tight. And this was, again, back in the 50s and 60s. This is not Berkeley like the Berkeley we know today, right? So, I think everyone pretty much agrees now at this point that he was right. It took 40 years, but it's actually, I think one of the other things that's interesting is that in a lot of ways, he has called out the aspects of deep learning that make it particularly useful for these fuzzy unstructured problems, right? The idea that it sort of fundamentally does away with this idea of a taxonomy, right? Mm-hmm. So just a fun little history lesson.
Yeah, I mean, I got to see a presentation and talk with a team that was doing sort of the old school NLP work for medical data. And
very common.
They actually had an ontological dictionary that mapped the shorthand notation abbreviations of different, not just doctor types, fields within medicine, but regional based as well. So apparently the Midwest in the US uses different abbreviations than the West Coast, which uses different from the East Coast.
Oh, yeah.
And they were trying to do a direct translation of this, the actual scanned documents of doctors' notes, and then create some sort of standardized format. And I had asked them, I was like, hey, how's all this going? That seems like a pretty hard problem. You got a CNN that's trying to do a detection, and then you have to run it through a conversion, effectively a translation stage. And the guy during the big talk in front of about 100 people, he answered my question. He's like, "We're making excellent strides and progress." And then after the discussion, he came by. He's like, "Hey, man, yeah, it's still broken." He's like, "We've been working on it for 35 years." And he's like,
"Oh yeah,
I mean, it does certain things, but he's like, you just have to keep on updating that dictionary. It's like the field changes so often that it's a constant battle." And he's like, "Do you know how big that ontological dictionary is?" I'm like, "I don't know, like 10 gigs." He's like, "Try 4 terabytes of like all of these mappings." And he's like, "We have teams of hundreds of people globally that are updating through a portal when like a new definition happens." I'm like, wow, that sounds painful. So yeah, I don't think that's going to be a solved problem in 3 years.
No, I think it's something that also people, it's something that gets missed in the AI debate sometimes, right? As we talked about the explainability of that, once you have a rules-based system of that size, nobody understands it. It's a non-deterministic system. Mm-hmm. We not maybe to that extreme, but I remember we talked to a customer that had, an old school regex system they were using to process something. They had 1,500 individual regex rules.
Ooh, my condolences.
And it's like, once you've got that, like, I know nobody understands it, right? I know nobody, like, you can't touch that thing without the whole thing collapsing, right? Mm-hmm. And I don't know, that's just, some people think that is a completely acceptable way to handle unstructured use cases. They'll be like, oh, it's great because it's explainable and I know exactly what it's doing. It's like, do you though?
Yeah, my rule of thumb when I'm talking to teams that are coming from a heuristics-based approach or a brute force-based approach like that is I give them the whiteboard test. And when I asked for that originally when talking to a team, they're like, "What are you talking about? Whiteboard test? I never heard that." I'm like, try to write your logic on a whiteboard, like a standard meeting room whiteboard. If you can't fit it, even if you're using like referring to your code and referring to some document, if you can't fit it in the way that you can write in a legible format on a whiteboard, then it's too big. There's no way you're going to be able to reason through this. And sometimes that is, okay, like I did one exercise with a customer where we were taking something that should have been a ensemble tree-based approach, like
sure,
random forest or something.
Yeah, super.
They were doing it in heuristics, which is just case statements in SQL, and we kept doing it
in SQL.
Yeah, it's just heuristics based.
Wow.
But I mean, the contrary is true as well. So if I've seen people using TensorFlow, and what they're really, to solve the business problem, it's 4 if statements, and it solves it to almost 100%, accuracy.
Absolutely.
But the opposite of that is the real problematic of like, hey, this is why ML and AI were invented. It's because we can't keep that in our cache, in our head, like reasoning through how this works.
Yeah. And it's like, being on the other side, I think especially more junior data engineers, right? Like this is the quicksand trap, right? And it felt like almost every use case, because it's like, you'll do it, like you'll apply the thing off the, and you're like, oh, well, I saw that issue. If I just tweak this one thing, the results are going to look cleaner, right? And it's like, before you know it, you've got 300 lines of disgusting logic and, it's 4 a.m. and you're like, is that supposed to be a 3 or a 4? And it's like, one of them is seg faulting, right?
Uh-huh.
Yeah. And like you just end up in that situation one too many times. And I think eventually like folks learn over time, just like how valuable it is to have a system with defined inputs and outputs that is trained, the same way every time. Yep. We had to institute a rule at Indico, which was like no touching data sets after midnight. It's just like, if you're doing test train splits and like moving CSVs around in your file system and you haven't slept, like you're gonna make a mistake, right?
Oh yeah.
I mean, those are disastrous. I mean, it happened because one night I literally spent 6 hours going through line by line a whole file of predictions, only to realize at the end that I had done the whole thing on the training data. I was mortified.
Been there, man.
Oh yeah,
been there.
And actually, the accuracy even improved on the test data was the worst part.
Yeah, and then you start wondering, what does this tell me about my architecture, or what does this tell me about my data?
What was I doing last night, right?
Mm-hmm.
Yeah, I'm just like, you know what? I'll talk to you in a couple of days. I'm tearing it down to the studs and starting over. It's just like I don't have confidence in this.
Right. Yep. I think anybody who's been doing this professionally for a number of years has always gone through that pain and been like, oh, geez.
Yeah. I think that's also part of just to like maybe tie it back to machine teaching slightly. It's one of the things that actually makes machine teaching really, really tough. And I think why people like classification so much is like people have gotten really, really good at sniffing those issues out in classification tasks. But you just got like even just stepping into regression, things like Simpson's paradox and making sure like, I don't know. I mean, you've seen this all the time, like back testing harnesses, right? In temporal like time series data, like everyone has that problem. And actually setting an appropriate backtesting harness up, I don't know that I've even seen one, frankly. It's such a hard thing to do. I'm sure like I've heard of them. I'm sure some people have them, but like it's such an immensely difficult problem. And people just don't do it.
Maybe the only time I've seen people do it successfully is when they're using Facebook Profit and using the internal cross-validator.
Okay, sure, fair.
I mean, we do it internally at Databricks with our ML team with our own forecasting use cases. But it is like by far the most expensive part of that execution is
really
the fact that
hard.
you're stepping through that entire history and saying, here's my time horizon of what I'm going to look at for training. Like, hey, 60 days of data, I'm going to test 14 days in the future, and I'm going to walk through and iterate. I mean, it becomes this O(n) squared problem in computational complexity, but in O to the n problem in space complexity as you're doing that, because you have to maintain that state of that time horizon going through as you're walking through state, like day by day by day by day. And then you have to figure out what metrics am I actually going to calculate here and how am I going to collapse that down into an overall goodness of fit for my model. Yeah.
And the ETL pipeline you've got to maintain to keep all of your timestamps aligned. And like, if you're off by a day, just disaster.
Yeah.
And like, and I guess like it makes more sense with the kind of folks, because like a lot of the folks that, I see this and we're talking like equity traders that have like tried to build their own back testing in Excel. Right. And you've got,
oh, geez.
Yeah. And it's just good. Like, no, it's not. It's like, bless their hearts for trying, but like I don't even think you could do that successfully or like, I don't know that I'd want to see it if you could.
Yeah, that's one of those let's pretend this does not exist sort of things if somebody did build it. But yeah, you need the right hardware, you need the right software to do it, and the right stateful machine in order to maintain a handle on that. Because doing a day level data and looking at a couple of years of data, that's trivial. But when you're like, say you're a supermarket and you're trying to forecast the demand of your top 1,000 products, it's one thing if you're a supermarket chain that has 30 stores in one city in the US. It's a whole different thing if you're Walmart and you're like, how many time series forecasts and backtesting and cross-validation do we have to do each day? It's like, well, it's 17.3 million that we need to run, which means in our training data set is 3 years of data. And we're forecasting out 60 days in the future so that we can optimize stock in our distribution warehouses. It becomes a much more complex situation there.
And it's one of those things where, I mean, you kind of pointed out the complexities are awful, especially as you start incorporating additional features, right? So I think in my practice, in practice, what I find is like, you almost have to just back solve for that. You're like, all right, how quickly does this have to run? Like, what time budget do we have? Right? Yep. Okay, great. How many features can we afford to include in this analysis?
Hey folks, it's Charles Max Wood, and I just wanted to jump on real quick and let you know that I am putting together a podcasting course. I get asked all the time. I've been coaching people for the last 6 months. How do you start a podcast? How do you put it together? What do I need in order to get it going, et cetera, et cetera, et cetera. I've put together the curriculum, and I did it through coaching a whole bunch of people, and now I want to share it with you. You can go check out the course. It's actually going to be a masterclass. It's going to be a 4-week masterclass where I actually walk you through the entire process of launching a terrific sounding podcast and putting together content that people want to listen to. And you can find it at podcastbootcamp.io.
Exactly. And it's not the approach. Yeah, it's not the approach that a lot of people try to do, that I see people come straight out of school trying.
Totally.
Oh, we have 15,000 columns. Let's try XGBoost and then see what the feature importances are. And just kind of tell them like, it's not going to give you the right answer. It's not going to be good at all. And it's not going to meet an SLA.
And even the worst part, even honestly, in a lot of ways, is like, I think one of the most dangerous things, especially when you're sort of like young in the field, is chasing red herrings, Right?
Yes.
That's what I always say is like the worst thing than an algorithm that doesn't work is something that doesn't work, but is going to convince you that it works or sort of looks like it's going to work. Right.
Yep.
Yeah. It's like so many times. That's what I see. It's like you just see people go down like the feature engineering path for like a million years. They're like, no, it's definitely there. I've just got to like remove one more feature and then suddenly everything here is going to work. And it's like, I always say, tweaks are going to get you from a good model to a great model. They're never going to get you from a model that doesn't work to a model that does work.
Right. Exactly. Or the other risk that I see young teams do is they'll throw everything into a model and they don't understand what the actual, autocorrelation values are between their features, or the fact that they could be inadvertently leaking the label on a supervised
that's
problem.
Especially in the backtesting scenario, leaking the label is so hard to avoid.
Oh yeah. Yeah. You have to carefully craft your features regardless of what technique you're using.
Yeah. And I think especially like timestamps are just such I don't know. We had to do this once with like stock forecasts and news. And like the awful issues like news, like it matters quite a lot what time zone it's in. Right?
Oh yeah.
Like that has to be plugged into your scraping system, right? It's just like, it's just such a nightmare. Because it's like, if you see something an hour early that caused a market panic, like suddenly that's your best model, right? And it's so hard to suss out I especially like time series. Like I consider myself pretty bold in going after problems, and like time series is one of the things that's like, all right, like let's slow down. That makes me nervous.
Yeah, because it's an incredible amount of investment debt that you have to commit to it. Yeah. And if you can't pay that debt off rapidly, you're just sitting there holding the bag for either a terrible solution that is actually not solving the problem, or a solution that kind of solves the problem, but is going to take forever to develop.
Yeah. No, 100%. I think I see people do the first one most frequently, right? Is just like, we're leaking data, but come on. Like what's some leaked data between friends?
Yeah. Look at my RMSE. Look how low it is. It's great. The model's perfect. Like, yeah, let's do an A/B test on that.
Yeah. No, I had someone like come in and present, and actually it was heartbreaking because like they built this thing with our system, right? And they're like, it is 100% accurate. And we're just like, are you going to tell him that he messed up? It's like, yeah, I'll do it. I'll tell him. It's just like, yeah, it's like the other lesson is just like, if you see 100%, like the most certain thing about that 100% is that you messed up.
Yes. You have put your label into your feature vector directly, and it has learned that there is one feature that is very important to predict this other feature.
Yeah. I mean, it's actually sometimes it helps you find the flip side. We found something funny with a customer that was convinced they needed this crazy like object detection NLP system to extract the like addresses. And we're like, this PDF has metadata, right? And it's just there, right?
Yep. Oh,
yeah.
I have since lost track of how many times that has happened. Customers of mine, as well as myself as well, where we just blind to obvious stuff because you're thinking, I'm going to apply ML in this in some way. And then, it's usually fridge logic that gets me. It's like you think through a problem, you're struggling through it, and then you go to the fridge at 11 p.m. to get, a bottle of water or something. And you're standing there with the fridge door open and it just hits you all of a sudden. That's what I call fridge logic.
I love that.
You're like, I bet that like the answer is actually part of the data we're trying to get. And there's no greater feeling as a data scientist than realizing that you can solve something either with SQL or Perl.
That's just, it's perfect, right? It's just like, wow, like I no longer have a problem.
Right.
Yeah. There's actually a one really interesting example. Did you do Kaggle competitions back in the day?
I never got into that. I was busy working when that came out.
Very fair. I was thankfully an undergrad. Kaggle. So they had this competition back in the day that was accelerometer. So it was supposed to be accelerometer identification. So the idea is they had a bunch of accelerometer data from phones, and they wanted you to, and they had like chunks throughout people's days. And the idea was you were supposed to like learn their daily schedules and then be able to figure out from the accelerometer data who was who. Cool problem. Difficult problem, to be sure, right? It turns out that accelerometers and it was like, the first couple of days, people were really, really struggling. It was some complicated metric, right? But, you're seeing like 0.6s, 0.7s, right? Like really, really struggling. And then one day, everything just like shoots up to like 0.999997, right? And you're like, what happened? And what someone realized is that accelerometers have mechanical defects generally because, and a lot of people don't realize this, accelerometers are mechanical devices. They're MEMS, which are like, if folks should Google MEMS because they're the coolest thing in the world. But right, so they've got these mechanical defects, and they'll show up because whatever, you've got 10 digits of precision or something. That's like, yes, the eighth digit in the binary representation is a 1 95% of the time, right? It'll be weird stuff like that. But I think they basically just switched it over, and instead of doing like any time series anything, they basically just did like digit level prediction with a random forest type model, right? And that's what shot up to the very top, right? Is they were just able to recognize those individual mechanical defects. And I thought that was like a really cool sort of inverted way, where it's like, I never would have thought of that in a million years. But it immediately showed up because someone just like saw really good performance out of a weird model that absolutely shouldn't have worked.
Yeah, and it's stories like that I tell to teams quite frequently, is that that is data science work. It's not the algorithms. It's not knowing everything about how the structure and architecture of some algorithm is built. It's more solving a problem in clever ways. I think in the field at a company, as a data scientist, nobody cares what tool set you're using, just so long as you're using the right tool set to solve the problem and getting it out there as quickly as possible.
Yeah, that's honestly, it's what frustrates me so often, I think, because I think there's a certain group of folks that will specifically advocate for using worse techniques and algorithms for some convoluted theoretical reasoning, right? And I think my point of view has always been that, like, as a data scientist, like, it is your ethical obligation to bring the best possible tool to the problem, right? And that's my view, right? And I think it's very, very simple. It's like, it doesn't matter if you got your PhD in traditional CV, right? Like, you're building something to detect cancer treatments, right? The CNN is getting 5 times the accuracy of your traditional like CV approach. Like, you have a responsibility to use that. I mean, like, especially in a case where like lives may literally be on the line. So that's, I don't know. I very, very much agree with that kind of framing, but I think it's becoming a more popular view, but it definitely rubs some folks the wrong way. I remember I was talking to someone at I won't share the name of this company, but it was at a company that was building self-driving cars. And they wanted to talk in a lot of detail about, I think he said something like, show me the like form of logistic regression, like write the formula down. And I was just like, it's like, okay, like I can do it. Like, I can go and I'll like figure it out. But I want you to realize that this is such a stupid question, right? Like, this is probably the stupidest possible question you could ask me. And I asked him, like, what are you hoping to get out of asking me that question? And he's like, well, I want to see how you reason about it. It's like, well, okay, great. Like, then ask me a question about that. And then I asked him a question. I was like, all right, so let me give you an example of what I think is a lot more relevant here is, think Wikipedia, right? So if you look at every NLP model basically trained, especially in this period of time, this is like 2018 or something like that. What's the problem with using Wikipedia as your one source for pre-training data? And he's just like, I don't know. That's a stupid question. That's someone else's problem, right? I just use the data they give me, right? I was just like, yeah, that's the problem, right? And I'm like, there's not, and it turns out, there's not a single personal pronoun in all of Wikipedia, right? And there's just like these weird couple of things where it's like, yeah, if you do a superficial investigation, it'll probably look fine, but it doesn't actually work. And made that prediction basically is like, wow, this self-driving car department is going to go belly up. And it happened, but $10 billion later.
Yeah, it's like, that's also some interesting stuff about in the NLP space. I was working with a company about 1.5 years ago, 2 years ago, that I was helping them scale out their NLP. And it was basically follow-on prediction. It's like a suite of tools that will do auto sentence completion and spell checking and context sensitive like classification of corpuses. And I was looking at the training data with them, and I was like, whoa, like, why do you have so many different disparate large data sets here in your training? Like, you have Wikipedia, then you have something that you have like an extract of Reddit, and then you have Twitter, like tweets that are in there. And then you have YouTube comments. They have like all these different things on the internet that are data sources that they could get. And they're like, well, the guy that I was talking to said, well, if we just trained it on Reddit, then the thing would just learn how to be an a-hole. And it's like, that's pretty clever and funny. But yeah, that context of encompassing as much of human communication on the internet as possible to get that good context was fascinating.
I think that's something that people also really, really miss. Is it used to be that you had so little capacity in models that it used to be about like really, really limited context, keep it as small and pristine as possible. And it has changed very much where it's like, no, we need as much as possible. Mm-hmm. I am also realizing we're at the end of time. I do have to run off to my next meeting.
Same here. This has been great.
So much fun. Yeah, total pleasure. Thanks for having me.
Yeah, this has been amazing. And I think we should try to get you on again for some additional topic and discussions.
I think it would be a lot of fun.
All right.
Look, excellent. Have a great day. Total pleasure. And have a great weekend.
All right. Take it easy, Slater. Bye.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.